Hello and welcome, ladies and gentlemen, to Law of Cosines. This is section 8.6 in geometry. Previously, we talked about the law of sines, which has its uses. The only time you can't use the law of sines is when you are given a triangle with only the sides given A, B, and C. That's one of the uses of law of cosines. So we're going to talk about law of cosines and how to use it. First off, what is the law of cosines? Well, the law of cosines is a little tricky. It's not as intuitive as the law of sines, so we're going to essentially not worry about the proof for today, but the formula essentially follows as thus. If you are trying to find a side A, so for example, in this first formula, we see that we have a triangle, and this would be if we have the other given measurements, and we're just looking for side A. There's a couple things we need to know in order to find side A. The things that we would need to know is we would need to know side B, we would need to know side C, right there, and then we'd also need to know the angle A. So you need to know three things in order to find the one thing that you're looking for. Now, it's also important to note that you can find other things other than the one side that's on it's by itself on the equal on that side of the equal sign. You could essentially find side B if you're looking for that one. You would just need to rearrange everything. You could find side C, or you could find angle A. So if you're looking for this angle, that's fine. You would just need to know B, C, and A, the three sides, and then you could find that angle measurement by using inverse trigonometry. So it's another way to go about solving for the triangle, just in a different way than the law of sines. Now, the same formulas can apply here. So we have this one is for b squared. I mean, it's the same thing. So you can see it's the same thing, except for the letters are just rearranged a little bit differently. So instead of cosine of A, it's cosine of B. So these match right here, B and B. Notice how there's no B in this area. Okay, just like there's no A in this area here. Okay, and then you have AC, AC, and there's also that 2 in there. And then for C, you'll notice something very similar. Whoops, I messed up. Get our C here, and then we'll style this red. Okay, so we have A squared plus B squared minus 2AB times cosine of C. I wrote times for the first one, and then just know that these are all multiplication here. 2AC is not just a unique variable, it's variables being multiplied together, and those are side lengths. Okay, so there's your three formulas for law of cosines. Essentially, like I said, they're the same thing, it's just for different sides. And if you wanted to, you could label the side, you could ignore these ones. Let me use a different color. You could essentially ignore these ones and just relabel the sides, so the ones that you want are A, B, and C respectively, and then label that one A. So, I mean, you could just use the first one essentially, but the other ones are there in case you want to use it multiple times. This is best for when you have three sides, because you can't use law of sines in that way, or side angle side. But you can actually use law of sines for this one, side angle side. You just takes another step, but we'll talk about that in just a second. So our first example, we have three measurements here. We have a side angle side going on, and we're trying to find the opposite side B. So what do we do from here? Well, the first thing I would do is label. So that's always going to be our first step. I like this one. So number one, we are going to label. And you'll notice here is B, so I need to match that up, and I'm going to call this big B right there. I'm going to call this one A, and then I'll call this one C. So if I call this big A, then that means this is going to be little a. And if this is big C, then that means this 10 is going to be little c. Okay, now number two, I'm going to plug into the formula. So which one should I use? Well, I'm looking for b squared, so I might as well use this second one here. So I'm going to just copy this guy, copy, and I'm going to paste him over here. I'm going to shrink them up a little bit, and then I'm just going to start inputting values. So B is what I'm trying to find. I'm going to change that to pink this hot pink here. So I'm looking for this b squared. Eventually I'm going to have to take the square root of that. Okay, so what are my other values? Well, I got equals a squared, well that's 22 squared, plus c squared, that's 10 squared, minus 2 times 22 times 10 times cosine, and we know the angle is 44. I'm going to have to move this guy down. I just got a feeling already. So you definitely need a calculator for this one. I mean, you'll need it for law of sines or cosines. But we'll know here that we have a big mess, so to speak. All right, so I'm gonna simplify this step by step just so you can see everything I'm doing here. You can maybe hear my calculator getting locked into place. So I have 22 squared. Oops, 22 squared. That gives me 484. I know that's 100. Minus 22 times 10 is 220. Times 2 is going to be 440. Times cosine of 44. I'm not typing that in yet because I like to do it all at once. So what I'm going to do first is I'm going to do, I'll add these two together first, and that will give me 584. And then now I'm going to type this into my calculator, 440 times cosine of 44. And I need to make sure it's in degree mode, so that's 316.5. 1. I'm going to go to the nearest hundredth here. Then I'm going to subtract this from 584, and I get 267.49, and that's equal to b squared. Now, do not forget to take the square root of both sides. That's a pretty important part, otherwise you're going to get a tremendously wrong answer. So I'm going to take the square root in just a moment. And I get b equals 16.36. And that is my side length. So that's how you use it. That's one long way to use the law of cosines. Now, I want to talk about something real quick. You could use the law of sines here, and I think it would be much easier. So imagine that we have the law of sines and we try to find, first we would need to find a missing, well actually no, we can't use the law of sines, can we? Yes, so for this problem we cannot use the law of sines just yet because we have too many angles missing. We would need to find at least one other angle. So this is a perfect example of why we can use law of cosines and not law of sines. Okay, because again, we had that missing information here. We only had one piece, and then we'd have either one piece here or one piece here, which you can't use law of sines for because you need at least 3 out of the 4, not 2 out of the 4. So you can't use law of sines there. Law of cosines has to be used. Here's another case where you can't use law of sines. We have angle A that we're trying to find, and what else are we trying? Okay, so we're trying to find just angle A. That's it, and we're given 3 sides. So in this case, we need to use, we can just go ahead and use this one right here because it's already got A in there. So let's go ahead and bring this down. Okay, we're going to use it in just a second. And then what we're going to do is we're going to relabel everything. So this is going to be A. We can just call this one B. It doesn't really matter what we call it. And this one's going to be C and little c. So angle A, what does it equal? Well, now we've finished labeling, plug in, and then last step, I forgot to write this, is solve. So our final step, well, first we need to plug in, step 2. Here we know A this time. A is going to be 4.4 squared equals B squared, 7.1 squared plus C squared, 6.7 squared minus 2 times, this doesn't matter which order I have, 6.7 times 7.1. Don't get confused with the decimals here. Just make sure it's obvious which one is multiplication. And then lastly, we multiply it by cosine of A. And you'll notice here, this time, we're trying to find cosine of A. So cosine of A is the one we are looking for. So I'm going to keep that in a different color, and then we're going to work on everything else. Let's proceed from here. So we have 4.4. We have a lot to do here. 4.4 squared. 19.36. 7.1 squared. 50.41. 6.7 squared, 44.89, minus 2 times 6.7 times 7.1. So we get minus 95.14 times cosine of A. And this is the tricky part. This is just equation manipulation. I need to move everything over to the other side to get cosine of A by itself. So what I'm going to do here is first I'm going to combine these, and then I'm going to subtract that from both sides. So here I combine these, and I get 50.41 plus 44.89, and that gives me 95.3. 95.3 minus 95.14 cosine, I want to change that color, times cosine of A. And this is equal to 19.36. So I'm going to subtract 95.3 from both sides. Starting to get the cosine of A by itself, minus 19.36. Okay, so I get negative 75.94 equals negative 95.14 cosine of A. Almost done to get the cosine of A, or the A by itself. First, I got to get cosine A by itself. I'm going to divide both sides by negative 95.14. Negative 95.14. When I do that, I get 0.798. I'm going to go 2 here just for the sake of accuracy, just to show you. What I'm essentially doing is I'm going to be saving the whole thing, which is about 8 digits on my calculator. I'm just showing you a fraction of it to give you an idea of how many places I'm going to. But I like to use the whole thing on my calculator because it automatically stores it. Now, in order to get the A by itself, right now it's being cosigned, so I need to take the inverse cosine of both sides to get rid of that cosine of A. So that's why I'm saying, okay, just leave it stored on your calculator, and now I'm just going to do cosine, inverse cosine of 0.78, blah, 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 or 79, sorry, and I get, oh, first off, let me show you, for inverse cosine of cosine, just gives me A. It undoes the cosine, and I'm left with A, which is the angle, and then on the left side, I get 37.04 degrees. So that is how you use law of cosines when you just have all 3 sides of a triangle, which is pretty useful. So it's really long, I get it, but it is useful for when you can't use law of sines, which there are basically 2 situations in which you can't use law of sines. First situation is when you have all 3 sides, no angles. You have to have at least 1 angle in law of sines. The other thing about law of sines is you have to have an angle paired up with its opposite side. In this case, we didn't know that measurement, and we didn't have the other 2 angles, so we can't use law of sines there either. So it's, again, best for side, 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 and side, angle, side measurements for triangles is law of cosine. Hope you enjoyed this video, and I look forward to seeing you next time on Wes Explains Best.